All right, moving on in chapter 21, we are talking about stationary points and points of inflection. Now, a stationary point is defined as any point where the first derivative, or f prime of x, equals 0. And it's called that because, you know, the first derivative tells you how fast you're moving, what your velocity is. So if the first derivative is 0, that means that your velocity is 0. So no matter where you are, it means that for that moment you're not moving. Now, whether you are switching from moving forwards to moving backwards, or vice versa, or whether you've just stopped moving forwards for a little bit and then you've decided to continue moving forwards, they all mean the same thing. The first derivative is 0 because your velocity is 0 at that moment. So we're going to find those moments and we're going to classify those moments. One of three things is going to happen when the first derivative is 0, if you have like a nice smooth continuous function, which is better than the one that I've drawn here. But in one instance, there might be a maximum. So you can see right here that if I were to draw a tangent line here, it would be horizontal, meaning the first derivative is 0. And this is a case where you have a maximum in the graph. The graph has reached a maximum point and now it's moving downward. It is decreasing. The second thing that might happen is the exact opposite, where it decreases for a while and then stops and then increases again. So that would be an instance where I have a minimum, or a local minimum in the area of those points. And the third thing that could happen is there is a point of inflection. So here is a case where it's increasing and then it stops momentarily, and I could put a horizontal tangent line there, but then it continues to increase. So that's not really a maximum or a minimum, but I do need a name for it. It's called a point of inflection. And we'll get into more of what that means when something is a point of inflection. But just for now, realize that it is not a maximum and it's not a minimum. The graph is kind of leveled off momentarily, but it keeps increasing afterwards. Or it could start decreasing, stop momentarily, and then start decreasing again. It doesn't switch from increasing to decreasing. So those are the three things that can happen. So let's do an example. We're going to find and classify all of the stationary points for this graph, and then we'll look at a picture to see if we're right. So taking the derivative, we have dy dx, and again, you can call it y prime, you can call it f prime of x, you can write neater than I do. This is going to be 3x squared minus 6x minus 9. And we're looking for where the first derivative is 0, so let's set that equal to 0 and solve. And if I factor this properly, it becomes 3 times x minus 3 times x plus 1. I kind of left out all of the intermediate algebra steps there, so hopefully you get to this place when you factor it. And that means that there is a stationary point at x equals 3. And at x equals negative 1. All right, so now would be a good time to draw my sign diagram. Negative 1 was one of the x's where there's a stationary point, and 3 is the other. So I'm going to try test values just to see what's going on outside of those 2 points and between those 2 points. So picking a number that is less than negative 1, let's pick negative 5. Negative 5 minus 3 is negative. Negative 5 plus 1 is negative. So I've got 3 times a negative, and that is going to be positive. So I know the function is increasing everywhere before x equals negative 1. Then I go to my second interval, which is everything between negative 1 and 3. So negative 1 is less than x is less than 3. I'm going to pick my favorite number, which is 0. 0 minus 3 is still negative, but 0 plus 1 is positive. So now I have 3 times a negative number times a positive number, and that's going to be negative. So this function is decreasing everywhere between negative 1 and 3. And then let's move on to some number that is bigger than 3. Let's look at what's going on after 3. So I'll pick a number like 4. 4 minus 3 is now positive. And 4 plus 1 is still positive, so I have 3 times a positive, and that is positive. That means that this function is increasing everywhere after x equals 3. So what's going on here? Well, I guess it's increasing for a little bit. It levels off at x equals -1. Then it starts decreasing for a little bit, and then it levels off at x equals 3, and then it starts increasing again. So just kind of a rough sketch of what's going on. And these were my 2 points. There's where x is equal to -1, and here's where x is equal to 3. Well, what would I classify that as? That would be a maximum. And what would I classify that as? That would be a minimum. So I don't have any points of inflection on here, but I do have one maximum and one minimum. And if you want to see what the real graph looks like, there's the real graph. And sure enough, there's my maximum at -1, and there's my minimum at 3. And you can calculate the y values if you want to just by plugging in these x coordinates into the original function to get your y coordinates. So that is maxes, mins, and points of inflection. If you have any questions, email me, and we'll work on this more tomorrow.